Yes,
Okay.
like
Yeah.
the mobile face. So whenever the mobile face gets changed, better to prime it first.
Okay.
So today you are running the sample again?
The BSA,
just for the
yes.
clarity.
Yeah.
Like I was
We will.
yes, yes. Today
yeah,
we'll repeat it.
we are
actually.
repeating it.
We are repeating it. Now we'll
Right.
repeat the.
From the start you were saying?
Yeah.
Start, from the start.
So first is the mobile face you have used.
Yes, mobile face. It should
In
be properly dipped inside.
Yep, sir,
It
that-
should be the filter. It is called the It's called the mobile face filter. It should be properly dipped inside.
So it is from the which?
No, it is from the A channel. I have
A
kept it
channel.
here. A channel.
Okay, fine.
You can use the mostly you will be using the isocratic methods. You will be pre-mixing the solvents in warm water. So you will be keeping in one of the lines. You can use the first line. So that is called A channel. A will be the tag.
And every rest will be.
There will be a tag here. So I can take it and sorry.
Okay.
I can take it and explain it. So B will be this is the B line. B and C. Yes. And this is the CLOS line. SW is the CLOS. And sample methods. This is to differentiate this syringe pulse. So they have given this line. And this will be the needle wash. The wash will be needle wash. So four solvents lines are called A, B, C, D. These are the mold based lines. Remaining three will be the wash lines.
So what is there now? I mean,
It is only plain water.
it's filter medium.
Like it is from the milling system.
Filtered medium. It is filtered
Filtered
medium.
medium.
Yeah. Or you can apply HPLC grade water also.
Okay.
Initially we
So
did
basically
and-
for the mobile face you are using channel A.
Yes, for channel.
Okay.
Yes. If you want to use a gradient, you can use
Then-
another three channels we have emptied.
Okay.
So that also you can use it.
Okay.
The tags are there. So if you remove the tags, it will be not easy to identify. But here we have the tagline. It cannot be removed. Okay. You can trace the which line you want to use. This will be there. Okay. And this is the easiest way. It
So
will be
color
the-
codes are there which are running through the system.
Yes.
So blue
Do that
means
also. If it falls down also, you can able to track it easily. This is the one.
Okay.
The same thing has been written here. A, B, C, D, C was
ठीक है.
okay. I'll just keep it back. Any doubts?
that's fine.
Okay.
Done. Come.
First thing, keeping the mold face in the mold face bottles appropriately by dipping all the solvent filters properly. That is the first thing. Then we'll go with the priming. And morning we have seen the how to turn on the instruments. So that I will.
Yeah.
That I have recorded it.
Simple thing. Yesterday he also did. If you have any question, come to me. It is all
Just
recorded.
it's
Just
Step
first
by
one is the
step.
middle one. And then
Yes, first one, yes, exactly.
And then
It's
the
a power on,
simultaneously
yes.
and then the
Exactly.
detector.
It's the power on buttons only. Just gently
Yeah,
press
yes,
it.
I know.
It gets insulated. And once everything gets insulated, you can log into the software. It automatically detects the
Yes.
all the instruments. Then it comes to idle. So everything comes to idle. Then you can come to know the instrument gets ready for acquisition or creating a sequence. Now I'll be doing the priming for the A channel. So we have changed the solvent. So I'll just keep in A. I'll just give priming for 5 minutes. Then let it be prime for 5 minutes, only the prime. In your CLOS, we have already primed the water. So let it be in the state only. So once you start, it automatically the pumps comes to the LED will be on. It gives some sound actually. Yeah. So it is the pump priming. So the flow will be collected here. That also you can see here. Once it starts, the flow it comes from the tank. This is the drain line, and
The pressure is zero.
the flow comes from here. So if it is going properly, the pumping is in the correct point. Okay.
Why is the pressure showing zero?
No, we are not giving any flow actually. It is doing the pump priming only. So it is not a flow actually. Flow is different, priming is different. Priming
Is
is
it washing the pump?
yes, it is
Not
washing
going
the
through
pump.
the
Yes,
piston.
It
It
is
is just
washing
like
the
that injection system also.
yes,
Just
it's
coming
piston.
and out.
It's
Yeah.
like a piston actually.
Take-
It is
it
just
is doing like
priming
a-
the pump.
Right.
If you are giving the flow, then it goes to the column, you will get a pressure. Then the closed loop will be there. It is coming directly to the drain. So it is
So
not.
it's not even going to the pressure
Yes,
sensor.
exactly. It is like cleaning the pump heads only. Okay, that is the thing. And the next thing I have explained them is like the sample manager. It consists of needle wash and the sample manager parts. This also you can prime it. If you change the water, and you can do it for 20 cycles, and you can do it for 3 to 4 times. The same setup. Again, once it gets completed, you can again do it the priming actually. Okay. This will be seen here through the needle wash. The needle wash comes from this output line. The flow goes here, and once it is completed, the syringe will be filled with the wash column. So the syringe goes up and down, then it gets cleaned completely. This is the needle wash. It is coming through this output line, and the syringe goes up and down. Then the syringe will be cleaned. once everything is be done, then our like we can ready to put through the flow to the instrument. So let it complete.
রেকর্ড করছে তো?
Yesterday we have that is the DSL. Same here we can need to check actually. And what it will just here we will just check it actually. Because like 0.5 is the minimum sample volume, right? 0.5 to 50 maximum. 50 microliters you can do.
Instrument quality.
Yes, instrument will take.
About how much volume we need to keep.
No, like we have the 2 ml vial holders actually. Maximum 2 ml you can hold it.
Maximum
2 ml, yes.
minimum I think 0.5.
Like minimum like 400 you can. 400 microliters is the residual volume. Maximum you can hold up to 2 ml. The injection volume you can take up to 50 microliters. You can use the like lower volume sample, the another vials will be there. Now we are using flat bottom vials. It does not take that.
What kind of wires do they use?
Now we have the flat bottom one. Yesterday he got some of the vials. Surajit has got some of the vials.
Some of the vials, no? The all vials are kept in here only. Made see for this as is road. So in future we have to run this 0.02 micron that filter we need, that catalog number on DSA we need, and then this type of vials I think I have to give extra for that. So then
we make
can you please today send at least a very rough estimate? Very rough. I don't want the exact.
Okay, I need to check with Surajit.
Yeah,
I'll just
check
note
it.
it down and I'll send
Please
it.
check it.
Okay.
Because he just told me that
yes,
we
yes,
need
yes.
to order
So
this,
what are the
and
accessories?
Tuesday is our that faculty meeting, so we will place it. So right, so we don't have time.
Okay.
Just we need an
Approximate price of it.
approximate price.
To maintain the
Yeah,
instrument
just
and
you
for
can tell me
maintenance.
verbally or by
Fine,
texting.
fine. That I can.
Right, including GST and all these things. What is the
Okay.
upper limit you are asking for?
Yes, we'll make a list, and after this, then we can schedule it. Now flow rate we can able to set it here. 0. Now ideally we are using at 0.5 flow rate. So now I'll be increasing the step by step. So this console, if you want, you can familiarize. If you are easy to use it, then you can use it, or else you can run through this all the parameters through this one only. HPLC Connect software. Now the console, it has been comes from by right click on this launch console. So that gives like detail thing what is going on in the system. Yeah, this is the one. If you are familiar with this one, you can use it, able to use it.
Okay.
If not there, you can use both are same only.
Okay.
So it will be like this one, it will be more detailed.
Okay.
how much the flow rate is going in the A channel,
Okay.
B channel and C channel will come. Now I have given the flow and it is going in 100% in A only. If
Okay.
I change it to B, B is in 0, now it will change it to 100 actually.
Mhm.
So that is the thing. And pressure also will be monitored. So why this console, this interface they have made in the sense like it gives a real-time identification.
Okay.
So I'll just click on the plot properties. So now, like you want to check whether the instrument pressure has been affected for the past 2 hours, for the past 10 hours or
Okay.
something else. So we can give it on the 10 hours. I will just give the time. So yesterday overnight it was loading in on the 0.2 flow, and it was around 600 psi or something. So we click on here. So 13.6, yeah, 7 AM. So that time it was 500 psi.
Okay.
After that you can click on here. So that time there is no pressure.
It,
Visual identification, it will be useful. This
Okay.
window.
so what does that indicate? It was switched off or something? Some error.
It gets communication.
Can you
failure,
put
actually.
the here? And what is the time it is showing?
Yes, it is showing 7:36 actually.
7:36 today,
Yes,
right?
today. Yes, today.
Okay.
Yes, today. That is the thing, and the same thing.
So
applicable for
what
all
went? What was the change therein? It was up to this solvent finished or something. What
No,
happened?
solvent was there actually. It went for a communication failure.
It went communication failure.
Yes,
Okay.
communication failure. Yes, maybe due to the
Power.
power loss or something. Maybe UPS.
Okay.
UPS, the capacity you can check with storage how much
Okay.
it can hold it.
Okay.
That is one of the reason. Due to the communication failure,
Okay.
has been stopped, or it may be due to the flow, like the
Okay.
sufficient mobile phase is not there.
Sufficient mobile phase was there.
Yes,
Means
yes,
that
yes,
is
Yes, that is
out.
ruled out actually.
Ruled out,
Only
right?
because of the
Only
power-
because of this
supply.
power
Yes, power
supply. Okay.
Apart from that, nothing.
So the thing is, if we switch it after doing the experiment,
Yes.
so after suppose daily maintenance, we should exactly switched off all the instrument or yours.
It is not recommended actually.
Okay.
So that is the reason you can only turn off the lamp and turn on the LEDs and everything.
Okay,
This one
so
can be
it will
be on
power
actually.
on all the time.
Yes, all the time.
But the thing is, it as
Yes.
you saw today,
yes, yes,
power
maybe.
might not be
Then
enough.
see,
What?
if your people they are not using the loading the samples overnight.
Okay.
So overnight in the sense 6 o'clock they are loading. Tomorrow morning they have to come and verify this. That time
Okay.
instrument will be running the overnight condition.
Okay.
Correct? That time it's recommended to on condition. If they are not using it, they are finishing their work by 5
Correct.
o'clock. Then they can shut down it. Then
Shut
tomorrow-
down in means
So,
complete
yes,
power
complete-
off,
yes,
right?
completely power off.
Complete power off.
And the third scenario, if they want to stabilize the instrument with the flow of overnight, yesterday we given a 0.2,
Okay.
like that they want to do it, then the instrument cannot be shut down.
In instrument cannot be
cannot be
set.
shut down,
But
okay.
last day when you just around 6:30 we went out,
yes,
right?
Yes, yes, yes.
Now the thing is how so that time this instrument was on. You
Yes,
kept
it
it
was,
on.
yes, we kept
It
it
was
on.
on power mode.
Yes,
That
it was
was
on power.
it showed that failure, right?
Yes, yes.
Okay.
No, it was on.
No.
Yeah, we have like given the proposed 0.2.
Okay.
It was on for the entire night.
Internet morning
or
7:30 there
There's
was a
been
power cut.
Yes, there's
So
a power cut.
we will avoid this one. Whenever we are done, we
That
will
is-
shut down, right?
Yeah, that will be better.
Complete
Yes, complete shutdown.
shut down.
You need to turn off the black points
Correct.
switches. Then you turn on the only instrument power buttons. That
Okay.
will be better.
Thank you.
Including the PC also. That will be better. Okay. And
So
yeah.
when the power went out and again came back, it reinitialized every parameter that was running.
No, that is why
No, that is
you
like,
can say
yes.
erratic. This, so
Yes.
this one.
So this is after
That
that,
is why
given the
I
primary
asked
but-
this one.
When the power came back, it automatically started again.
No, it won't. It
It
never
won't-
starts actually. It will comes to ideal only.
Just arbitrary values.
Yes, yes,
Yeah,
yes.
random some values it.
Yes. No, it won't show the value actually.
Okay.
It won't give the flow. Once power shutdowns, it's like instrument went to off mode.
Off
So-
mode. Now my question is,
Yes.
what is this one is okay, but this one
No,
start.
when I came here, after that I started the priming.
Okay.
I started the priming, I started the flow. So now the flow is going up. So
Okay.
it will give the pressure actually. I'll just I'll just keep the cursor here. Yeah. It is now 11 something. This is around 9:30 or something. Okay. Yes, 9:49. So that time nothing was there. When I came here, I have primed it. I have given the flow.
Mhm.
Okay, that is the thing. The flow we can increase it like 0.2. So let it stabilize for some time. Slowly you can apply the flow rate. So directly don't apply the maximum flow rate. Like 5 ml is the flow rate set flow rate for your analysis. Don't set it as 5 ml directly. Just step by step you can go slowly. Just wait for 2 or 3 minutes. Then increase the flow rate. So this interface will be very useful. You can easily track what happened for the instrument in the past. This is for only the pump. Like system pressure is called the QSM system pressure. That is the pump one, and flow rate A channel what is the flow is going on, B, C, it will be in 0 conditions only. So then you can track the sample manager temperature as well here. Sample manager, you click here and it will be showing the room temperature. There will be inside temperature sensor in the in the sample compartment, as well as it consists of temperature probe for the column and sample module, formatting the sample temperature as well as the column temperature. These sensors are here, so you can set the temperature as 40 degree or something, or 30 degree as per your requirement, and that can be tracked here. If there is a fluctuation in the temperature, you can easily come to know. This also by we can check it by right click on the plot properties. I can give the 10 hours time or something, and I can check it. Okay, it gives a much more better idea than anything else. Okay, this can be done through by right click any of the modules, right click, launch console, then automatically it comes here. It's clear, right? So then we'll just go with the get initialize. And the main thing, the pressure, once it gets stabilized, we have to see the HPLC pressure through this console only. If the pressure fluctuation is there, how we can able to identify? So the pressure will definitely fluctuate. So the difference should be less than 50, then it will be well and good.
Yes.
If the difference is more, if 900 pressure is there, it comes to 1000, again it's going back to 500, then there is a huge fluctuation. Then your flow is going and it gets choked inside. So in that case, you should not run. Just wash properly, then you come back and give the flow. So whenever you are applying the flow, there will be a closed loop. So from the pump, it goes to the column. From the pump it goes to the sample manager. Sample manager, it goes to the column. Column outlet, it goes to the UV detector. From the UV, go to the non, then optilab, then coming to the drain. So then it will be in the closed loop. You will get the pressure exactly. The pressure, it is getting built. It is depends on the column only. If there is after giving the 0.5 ml flow, you do not see a building up on pressure, then there will be a leak. The chances. Physical leak, you can check it. Okay.
Okay.
Just a second.
I guess we should keep a track of what pressure corresponds to what flow.
Yes, this column for the PBS mobile phase, below the column temperature, it's giving around 1400 to 1500. So we have seen 0.5. Yes, 0.5. If you change the mobile phase, obviously it will vary, and if you increase the temperature increases, pressure will obviously decreases. So that is the method. The physical connections, these are SS connections. So there won't be any leak. There won't be any leak. I believe. And this is the plastic tube. I just tightened it by hand. If I tighten it by spanner or any wrench or something, it may break. So I just done it a maximum tight. If maybe over a period of time, maybe if you find the pressure is not building, you just check here any leak is there by touching here. So if it is dry, then it is well and good. So remaining all connections are SS connections, SS tubing, 316 and 304 connections. It never gets rusted. There won't be any leak. Okay. So these are the plastic connections I feel. And this is like normal, it comes by gravity. The pumping part, main thing, the SS connections is going here, and there should not be any leak in the SS connections. Usually it won't be there. So the main worry about this, you connect it in peak tubing. So there is a hand tight only. So if any leaks comes, it comes from here, and if more bracket pressure is created. And the next thing is leaks come from here. This is the column inlet end. We'll be tightening it by hand only, the hand tight. So we will get a leak here and we will get a leak here. That's it. So the pressure after giving the flow, it's not building up. You can check here and check here. These are two things. It also very much tighter. It never comes. You will check the column connection first. Okay. The column pressure only it's showing us. So apart from that, nothing. The end, if you remove the outlet of the column, it may give around variation of 100 psi. That's it. If everything in the closed loop, it may give additional of 200 psi. That is the thing. Up to the column, it gives around 1400 psi. Once I connected, it may give a pressure of 50 psi. That will give a pressure of 50 and 50. Close to with the difference. Everything is in a closed loop, and it will comes around 1500 to 1600 maximum. The temperature, without the temperature. Previous mobile phase and this column, particular column. Yes. Depends on the column, mobile phase, and everything gets varied. Okay. The pressure is the main thing for controlling the HPLC. That should be proper, the first and foremost thing. And the signals for the MALS, you can see it in the display. The signals, yesterday we discussed it. So once it will be the signal, output signal we are getting in the detector or not, it comes to the forward monitor. It should be always in the ready state. and remaining signals once you give the flow and washing properly, so it gets stabilized and it comes to the ideal state. So red is the warning state, not ready to run, and orange is the yellow, that is the warning state. The ready state, that is. So it's the entire stabilization, in the sense the flushing can be done with the water, for 1 hour for every before every analysis, every like your method setup. Once you keep the PBS something, you just prime the A channel, and remaining channels already you are primed with the water. Then you give the flow, initial setup with the 0.5. Then let it flow goes for 3 to 4 hours. Once it allow the instrument to stabilize it, be patient. Once it comes everything fine, the signals everything good, then you can start your analysis. Like you are making an urgency to start, it may affect something and you won't get the results appropriately. So be patient and doing these things a lot. Yes.
I mean, just reading yesterday's one. So after the priming, you are telling to run the mobile phase for 3 to 4 hours.
Yes.
After
yes.
the priming.
After the priming, you just give the flow. Then mobile phase.
Flow at 0.5.
No, it depends on your method actually. Anyhow, you are doing the research actually. So my BSA and these things will run as a certain parameters that has been defined. So my flow rate is 0.5 I am using it. So your method we can able to.
But the general
any
washing step does not depend on the sample, right? I mean,
no washing step in the sense, no, you are using the mobile phase. You are going to run the your analysis, correct? You are going to start
Yes,
your
yes.
method. That method having some flow rate actually.
He's saying that before running his sample,
Okay.
he will be run with this. You will be running this,
my mobile phase.
Yes.
my run. That is what, and that will take 3 to 4 hours, right?
Yes.
Oh.
That way. Whatever the mobile phase, you just whatever the mobile phase, you just run it with
Yeah,
3
that
to
is
4
fine,
hours.
but I am telling that depending on my mobile phase, the flow
Yes.
rate used suggested at 0.5 based on the BSA.
Yes.
For the
yes.
BSA it is 0.5.
Yes,
so
exactly.
for my sample it might be different.
Yes, it might be different.
I mean, how to optimize that?
That we have to, that only we have to see. That application part we have to take it on us.
Because he is a technical,
Technical person. I know the operation.
The good person to ask this kind of this
Application
Leo.
guy. Leo.
Urpita. I will send the link address. So we will be having a separate session with him.
Yes. See
So
now.
in
yes.
standard, please.
No, it's just.
I mean, just for the clarity, I mean, does it depend on the concentration?
No, nothing.
It doesn't
nothing.
depend
No,
on-
so usually it will range 0.5 to 0.7.
Okay.
So to if you are running in 0.5 flow rate, your RT may vary. If you are increasing the flow rate, the RT may vary actually. So you have to optimize it. So by doing the trial and error, we will come to know. I cannot suggest you this flow rate you will do, you will get a molecular weight. That is the thing. Yes, that is the challenge, sir.
That is the
Now, ideally, you give the 0.5, and it should be stabilized for 3 to 4 hours minimum. Actually, I'll tell 4 hours actually. Then
Even
yes.
the application specialist, Leo will be he will give you a broad answer.
Broad only.
So only answer to this the selection trial.
Trial, yes, exactly.
So
He
you have
also
to
tell.
find a good literature who can give you the probable values or the probable range. But for this you have to dig on.
Yes. Actually,
Fine.
we have to do
Multiple,
some tuning.
Yeah,
Yes.
some tuning and all this.
So then,
everything.
then only we can able to get the results.
That's the main challenge.
Main reason we have injected BSA. BSA we know the molecular weight, we know the size, and we know the defined standard parameters. We know the column size and everything. If we injected it, we got the results as expected, and we come to know the instrument is working as antibiotic.
Okay.
Then we injected the protein, but we did not get it actually. That we have to work on the separate case yesterday. So once we have the standard in our hand, we can able to see whether the
He is
instrument
only field engineer. So whatever whatever your questions are regarding your sample, come with your own. Suppose you have enzyme, come with those of set of enzymes, and please come with literature. Don't say in the literature as a whole. Please gist it up.
Yes.
Leo is the application manager.
Yes.
Right. So he will be at least give some hint how to approach.
That's it.
There are some basic rules for all like enzyme, whatever you are bringing in, that should be filtered through 0.02, not 0.2, 0.02 micron. That's the costlier one. This is one of the things, and the second thing I think, this one.
Stabilizing the system requires around 4 to 5 hours, then it would be better if you could run it overnight.
The thing is, but in that case, that will chalk it out, because I cannot, you cannot. The power is erratic.
That is
right.
That is
Erratic
one.
power cut.
So in that case, we can suggest you come 9 o'clock in the morning.
early
If
in the
earlier,
morning.
before day, you can prepare the samples.
Yes.
Copy the time. oil phase we can keep it for one day, right?
Yeah.
Validity will be oil phase will be one day. We keep it ready by yesterday evening, today evening, and tomorrow if you come in the morning you can
Just like puja and all this,
Start
you know,
it.
they stabilize the pressure. That's
Yes.
the one problem. So stabilize the pressure, and you have to run at least 3-4 hours. Because the thing is, you are not doing only HPLC, you are doing the multi-scattering also. The small particles will give peak in loading.
So that is the one thing. So before you are approaching our application scientist, you have the information about in your hand, like so many details from your end. And the literature mainly, if you suggest him, he can also suggest you the broad range of
Broad range of-
broad range. He cannot exactly tell you this works or this works. So you have to do the trial and error. So that can be done in the next session. I just wanted to talk to you. So
See, these guys also, they do SPR, so you know, at some point of time, we need application
yes,
specialists.
yes, exactly.
As I am told that Ziva and all, they are very competent about this one. They suggest at least basic tutorial, then they have to so one time. Okay?
Okay.
So,
We just will create the instrument method. We can.
okay. We'll create here, no? I will
Yes, I will. The document wise and everything, do's and don'ts, that we can prepare it later, okay? So that, okay. So this is, I'm having everything ready-made one. So this we'll optimize it and I'll give it to you, okay?
Okay.
So everything will be there, okay? Inlet and outlet, everything will be there. So this we'll sit and we'll together on make a
Sheet, I will
spec sheet
print it
and
now.
we'll print it here.
I will print.
We'll print it and the specifications also we'll make a printout,
ठीक है.
injection volume and temperatures, okay? So yes. Now I'll just go here. I want to check the data for the last like 15-20 minutes. I'll just give it like timing of last the 20 minutes. It goes here like I have increased the flow rate, the step by step 0.1, 0.2 like that. And now it reaches in the 1600 psi. Flow rate is 0.5. Now it is reaching around yes 1600 psi. So how we can able to see it in the sense like 5 minutes I can see. Yes. So we'll get a straight line over here. Then the delta psi, the difference will be less than 20 or 30. Then it gets, and the difference you can see 1643, 40. So this is the difference I'm telling you. The fluctuation, if it is within the like minimal range, then your instrument gets stabilized. It's the meaning that instrument is in a steady state. If there is a fluctuation more than 1300, 1800, 1500, like that obvious, it's a 3-digit variation will come. So then that time you can see your instrument HPLC does not stabilize. Okay. Yes. Yes. We have not put any input for temperatures, so let it be in off and it takes the ambient. So I'll just minimize it, and this also in a ready state. Now we can create the instrument method.
Instrument
Instrument
method,
method, yes.